Students, welcome again in ASOC Tutorials India, and today's session is Inductance Explained Part 1. Hope you will like this new innovative way. Hello students, before I go through my today's session on inductance, let us have a look on a board. Just have a look on the board. Here you can see toroids, transformer, it is inductance. Same way these are also inductance, and this is transformer, mutual inductance, and this is also in same way you can see lot of other components also. Even here also you can see there is also inductance. So detail I am going to discuss now. This is my small setup to make a video recording, accessories, today's session on inductance part 1 with a lot of papers, pens, papers and other miscellaneous accessory. The first question is coming, what is coil? Any wire loop is called coil. Even we can make it with coils with specification. You can see I am showing you example. This coil can be a circular, cylindrical or even spiral or any type. And this coil is also called choke. So this is an example of coil. Nothing is inside, so this is air core type, going to explain you later. Now coming to the next, what is inductance? Inductance is a name given to property of component that oppose sudden change in current. Inductors are used for slow down current surges or spike by temporarily storing energy in an electromagnetic field and then releasing it back into the circuit. They are of several types. First one shown you as air type. Second one going to show you as a iron type. Just putting an iron and showing you. You can see putting iron, and this is I type as a spacer. So this is iron type. And third one is ferrite type. See, this is coil. This is ferrite. Going to insert it. Now going to lock it. So this is ferrite type inductor. Next question is coming, what is standard international unit of inductance? The inductance unit is Henry. This Henry name given after Joseph Henry, but same time this also remembered, this is also a unit of Weber per ampere. Or we can say 1 Henry is equal to 1 Weber per ampere. This one keep it in your mind. When we are studying about standard international unit SI, same time it is also important to understand permeability. What is permeability? It is a characteristic of matter and is important in the design and construction of electromagnets, inductors and alternating current AC transformer, which I am going to discuss later. But same time one question is missing, going to tell you the difference between inductance and inductor, capacitance and capacitor, resistance and resistor. When the term is coming resistance, inductance, capacitance, they are all properties. And when coming to the term resistor, capacitor, inductor, they are physical devices which have the property for resistance, For resistor, the property is resistance. For inductor, inductance. And same way for capacitor, capacitance property is being used. Same time, it is also important to see the symbol of inductance. Symbol of inductors. As I told you, first one, this one is symbol is of coil, and same one is used for air type inductor. Next one is coming iron core type. For iron core type, we are using two parallel straight line. This one is called iron core type inductor. Third one is ferrite type. For ferrite type inductor, we are using dotted line. This one is called ferrite type inductor. In future, in next part, I am going to tell you about transformer or variable inductor. That I will tell you there itself, not here. When we are discussing about the properties, it is also very important to understand the permeability. What is this term? It is a characteristic of a matter. I will show you. So this is characteristics of a matter and is important in design and construction of electromagnetic induction inductors and AC transformers. I'm showing you, this is relay, this is inside. So when you are going to design it, same way, this is transformer, and you are going to design it, see inside, it is very important to think everything. Same way, it is also very important to understand the electromagnetic induction law. Electromagnetic induction law. What is this one? For here you have to understand Faraday's law, also Lenz law. They are very similar. So first one, Faraday's law, it indicates or says induction. This describes how an electric current produces a magnetic field, and conversely how a changing magnetic field generates an electric current in a conductor. I hope you have seen my previous parts, magnets. It is shown clearly there. Inductors are of two types. First, self-inductor or inductance. Second, mutual inductance. So what are these two? So coming to the self-inductance. So what is self-inductance? It is the ability of a conductor to induce voltage in itself when the current changes. When current flows through a coil, a magnetic field is developed. Just holding here. See, this is a coil. Just momently pressing a switch, this battery, this charge will generate a magnetic line. The moment you switch it off, disconnect it, this energy will be released and create voltage. So this created voltage, when it is AC, in case of AC, it will oppose to change in current, and when it is DC, it will work as a magnetic coil. So both principles are in use. So better go through practical also. Just I am continue here. If the current is changed, the line of force applied to coil will also change, which will induce a voltage in the coil, and this one is called self-inductance. that you have to remember. Here I am adding one more thing. If we bring another coil in the same field, then this flux will link with other one, and this will induce voltage in this linked coil. This voltage in linked coil is depend on several parameters like number of turns, used core, voltage, frequency, etc. And this one is called mutual inductance. This mutual inductance example is transformer. Transformer is not a small topic. It has several type of transformer: auto transformer, bifilar winding transformer, single winding, multi winding, single phase, polyphase. So this one is very big, and of course calculation is there. This one I am going to cover in part 2. So please watch part 2 exclusive on mutual inductance, transformer, their calculation and parameter. Part 1 I am continue with self-inductance. So self-inductance coming back, which opposed to change in current, and this one is depend on several parameter. First one, number of turns. Second one, this cross section area. Third one, used core, because it will allow more flux to pass through. And one more thing, it is also depend on type of core used. This is EI core, this is C type farad, and same way you will get it L and other type cores also. So this one is also very important factor. When you are looking so many property, it is also very important to understand what is 1 Henry. This is a unit, 1 Henry. 1 Henry is the value of self-inductance in a closed circuit or coil, which 1 voltage is produced. Remember it. 1 voltage is produced by variation of inducing current of 1 amp per second. This one I'm not going to explain in details. Maybe examiner ask. So remember this 1 Henry also. This is very important. Before I close the session, just take home points. First, an inductor opposes or resists the rate of changes of current flowing through it at its source energy supplied by source voltage within its magnetic field. This ability of the inductor to oppose current flow is called inductance. Clear to you? This one is point 1. Coming to next point 2. When the this switch is open, there is no voltage supply or available to maintain this magnetic field around under. So this voltage slowly decay going down, and it changes in current flow, creates the induce an EMF back to the same circuit. It means the energy which is already stored in inductance will be slowly released back to the circuit even there is no power and switch is off. This is point number 2. If you want to go in more detail, it is very important to understand Lange's law, but I don't think it is important for you for ASOC exam. So coming to the next point 3, take home point. The direction of the self-induced EMF coil is reverse the supply voltage. Listen carefully. The direction of this self-induced EMF in the coil is a reverse of the supply voltage, which create the magnetic field. This is the reason it is called back EMF. So note down, self-inductance create back EMF. That is very important. Now coming to the fourth take home point. Inductor resists the change in current. Inductor I resists the change in current, whereas capacitor opposed to change in voltage. That is very important. This is point 4. So I'm going to end this topic today. If you like it, subscribe it. If you want to continue, please watch part 2 also, because this mutual inductance transformer is very important, and this part 2 will continue to part 3 as reactance and maybe resonance. So they are very important topic. So in between I had to cover you. So this is my thank you. 73 to you, DE VU2 SD Sushil. See you again. Bye.